Welcome, everyone. We are grateful to be Zooming today from Treaty 1 territory, the original lands of the Anishinaabe, Anishinaabe, Dakota, and Dene people, and the homeland of the Métis Nation. The hydroelectricity powering my computer is generated in northern Manitoba, which is Treaty 5 territory. The water that sustains us here in Winnipeg comes from Treaty 3 territory, and we have Shoal Lake 40 First Nation and acknowledge their struggles for Freedom Road and to have safe drinking water access themselves. As treaty people, we acknowledge the damage of the past and present and commit to work in meaningful partnership with First Nations, Métis, and Inuit peoples. The Minnow-Bemadiswin Partnership, which means practice of a good life, focused on building partnerships and capacity with First Nations on community-led initiatives, also works and benefits from these territories and their resources. Please take the time now to write in the chat the territory you are Zooming from and the territory that is the source of your water. I will now introduce Dean Stephan Pflugmacher Lima. This September, Professor Stephan Pflugmacher Lima began his role as Dean of the Clayton H. Riddell Faculty of Environment, Earth, and Resources. The Dean first received his biology diploma from the University of Ulm. The Dean received his PhD in biology focused on ecotoxicology from the University of Munich, and he then traveled the world, which we can only wish to do at this point, doing postdoctoral research in Berlin, Scotland, Brazil, Argentina, Australia, and China. The Dean has conducted research and taught as a full professor and chair in ecotoxicology for 7 years at the Technical University of Berlin. He then joined the University of Helsinki as a professor for urban ecotoxicology. We're lucky to have him here today presenting on smart city planning and smart urban water bodies. He will present and then we will open the floor for questions. Thank you.
Thank you very much for this nice introduction. I will just try to share my screen on that. So, good afternoon. I'm very happy that I have the possibility to talk to you this afternoon and to do a little bit of science beside my dean's job, signing papers and thinking on the how to bring the faculty forward and all these things. So the topic of today is smart city planning and smart urban water bodies. And I would like to show you how I try to translate science into applied applications. Let me start with the traditional territories acknowledgement. The University of Manitoba campuses are located on the original lands of Anishinaabe, Cree, Oikree, Dakota, and Dene people, and on the homeland of the Métis Nation. I respect the treaties that were made on these territories. I acknowledge the harms and mistakes of the past, and I dedicate myself to move forward in partnership with indigenous communities in a spirit of reconciliation and collaboration. So let's see that. Urban green spaces, urban water bodies. At the moment, we have a lot of smart things in our life. We have smart buildings, smart homes, smart society, smart education, smart care, smart energy, smart mobility, smart recycling, and smart IT. And my question was, are these urban green spaces and urban water bodies, are they smart? Are they already smart, or how can we make them smart at all? So in the beginning, I would like to show you pictures from the homeland of my wife. She's Brazilian, and this is Rio Tide, and in the there's the skyline of Sao Paulo in the back, and that's a typical jungle river coming down to a city. And when you look at how the river is then transformed to more or less channel pressed in a concrete bed. It's a little bit like raping on the river on that. And passing Sao Paulo, this river is used as a trash bin. So everything goes in there unfiltered, and it's the most polluted water you can have. That's the view when you fly into the international airport of Sao Paulo. If you have a window seat, you can see it like that. If you get out of the airplane, the smell you have immediately in your nose is not the person in front of you. It's already the river, which you can smell on that. So shortly after Sao Paulo, the river looks sometimes like that. You see there's a lot of climate change. No, in fact, it's not ice covered. It's some detergents which are sometimes in the river, and the water quality is still very, very bad on that. But a few hundred kilometers away from Sao Paulo, the river changed its face again, and it looks like a nice river. There are fish inside, there are plants inside, the water quality is really getting good. And that's why I would like to start my presentation with this statement. There's nothing smarter than Mother Nature. So if you look at that and keep that in mind during the presentation. So when I was a young man, ages ago, my doctor father, Heinrich Sandermann Jr., and former research minister Klaus Töpfer, we were working on a project comparing what a liver can do with what plants can do. And we call this the green liver concept, because we were thinking on the liver is detoxification organ of our body, and plants might do the same in our environment. So my job was to compare adverse outcome pathways, similar biotransformation enzymes, and similar metabolic pathways of human livers with those of plants. And I started with small algae, then I went to marine algae, including Arctic and Antarctic one. I had macrophytes, higher plants on that, and even sometimes I have these sequoias screened on that. I see that the similarities are big in that, and the only exception is that we are excreting metabolites, we are excreting toxic stuff via the kidneys and the urine, and the plant can't do this. So the plant is normally storing these metabolites or the xenobiotics taken up in the vacuoles, in apoplasts, and in cell walls, in cellulosis and hemicelluloses. That's actually the only difference on that. So I screened all these plants, and when you see my doctoral thesis, it's several hundred pages long. So after a while, I was thinking on, when I got my PhD, so what? I had lots of plants, I had lots of data screened and all these, and what to do with that. And I was getting a little bit interested into phyto remediation. So how can I use these plants to do something with that? How can I use all these fundamental information on enzymes and biotransformation pathways to really use it? And when you look at phyto remediation and all which comes with that, phytostabilization, volatilization, stimulation, transformation, and extraction, and I was thinking on how can I put my data in relation to that. When we look at macrophytes, and that's what I was doing when I was a postdoc and starting in Berlin, I was very fascinated by these aquatic plants spending all parts of her life cycle in water. And then, of course, there are different plants, and they are also growing in different parts of a lake or of a river. And when you look at these plants, and the next picture shows it, it shows you the beauty of these plants. And I'm always fascinated by them, how really beautiful they are. And of course, I was thinking on they are beautiful, but maybe they can help us as well. So that's why I was getting more in this research area. I was trying to learn what plants can do for us. So I was setting up monitoring programs using plants and exposing plants to different xenobiotics. I was screening 175 macrophytes, 45 marine macroalgae from including the Antarctic and Arctic ones. I had microalgae in the program, cyanobacteria, and 2 water fungi. So with that, I was trying to put everything I learned during my PhD and my postdocs. So I was doing all the analytics with HPLC and with quadrupole mass spectrometry to see uptake, biotransformation, where do the plants store these metabolites, what they are doing with them. And yeah, that generates, again, a huge data set. And this huge data set looks a little bit like that. So they are aquatic macrophytes, different ones. And then this picture shows you the uptake of diclofenac, the painkiller, into these plants. And as you can see, plants are like humans. We are all different, and that's good. And also plants are different. There are some plants which are pretty good in taking up these diclofenac, these painkillers, and we have plants which are not so good in taking it up. But if we look at different cyanobiotics, for example, not only diclofenac, but also maybe heavy metals, then you see that maybe these plants, which are not good in taking up diclofenac, are very, very good in taking up copper or cadmium or nickel. So that's how it is. Plants are different as humans are different as well. When you look at the time dependency, you can see that there are plants which are very fast taking up these diclofenac and other compounds. And we have plants like these Fontinalis antipyretica, these little water moss, where this uptake is slower on that. But if we just expose these plants also to heavy metals, you will then see how these changed. And then Fontinalis antipyretica is like a little sponge in taking up heavy metals. So again, plants are different. And that's why I thought on maybe I can use plants and use these ecosystem service they provide in taking up and metabolizing xenobiotics. And I was seeing plants more and more as a tool. Of course, you can have putting a nail into the wall using a screwdriver. That's possible, but it takes a little bit more time. Or you can just break a pile of wood with a hammer, but it's better to take a saw. So again, plants are different, and plants, from my point of view, are different tools. So what I developed was a toolbox. And you know, that's typical man. If we can buy a fifth hammer and we are happy with that, then we do it. And for that, I was developing this toolbox, and I was thinking people will come and will tell me, okay, this water body has this and that problem. And then I go to my plants and will choose the ones which are best to cope with this problem. So really a toolbox for an environmental problem. So that's then what I built up. It's the mother of all green liver systems. It's a self-made plexiglass tank where the water can flow through. We have barriers inside to separate the plants, but the water can pass by. So that's only to keep the plants a bit away from each other. And I can control the flow in the system as well. So why separating the plants? Because in an aquatic water body, normally you have a fight on nutrients, you have a fight on light and on space. So the plants sometimes don't like each other so much, and they are putting some chemicals out to kill the other plants, or to just keep them small and don't let them grow so much. So in this kind of a system, you have to learn which plants are good in what place and which plants are not so good if they are next to each other. So that was the first things which we were doing on that. And then, of course, we had a bigger tank and more professional with LED lights and moonlights and all this kind of stuff. And we looked at plant species composition. We looked at the ratio of plant biomass to water volume and retention time, flow rate in relation to overall performance of the system. influence of the shape of the system. Is it okay to have these rectangulings, or is it better a round one, or whatever? The shape of the barriers was an issue to avoid dirty corners within the system. And you can see it here that we bend these barriers a little bit to make the flow easier. Supportive installations, for example, sand filters, adaptation to different ecosystems, adaptation to different climate conditions. That's what we try to do with these kind of systems. We had another one looking a little bit like these Chinese rice fields. It's a complete separation of the plants in different tanks, and only we let the water drop from one area to another one. Also, this brings in additional oxygen, which is good for oxidizing substances and also good for the plants itself. Then we were comparing two systems, which one has the better performance, and that was quite a bit of work which we were doing the past years on that. So I get more and more, and you see me here, I was 10 years younger. I got more and more that let the plant do the work. They do it in a good way, and they do it in a perfect way. And we have just to see which plants are helpful and which plant combinations are helpful for that. So when I was ready to set up a bigger system, before I was just looking around who can do a proof of concept. And I find colleagues at the Nelson Mandela Metropolitan University of Port Elizabeth in South Africa. And we provided them with all we know about the plants, all we know about setting up the system. So of course, we have to trust them in a way that they are helpful to us and not just taking all the information and doing their own stuff. But it was a very nice cooperation, and we got a good proof of concept that the system we developed and the plants we had, that it's really working out. They even modified a little bit the system, what they have, but it still worked perfectly. And we had a nice proof of concept on that. So thanks to the colleagues in South Africa for that. Then I got more and more into urban ecotoxicology. You know that in a few years to come, 70, 75, 80% of the world's population will be living in a city. And the normal city view would be that. If you give me a little bit of time in Photoshop, then we go to the other side of the picture and it looks like more lively and green and all this. So like people would like to have the city, but that's actually the point of view we have at the moment. So as I'm an ecotoxicologist, I was thinking of what can I do to ensure that we are all safe living in these kind of cities, and that the environmental burden, the pollution burden these mega cities are producing are buffered in a way. So if you look at these cities, we have an increase in water consumption, clear, we have more people living there. Increase in food consumption, we have therefore an increase in the waste production, and overall an increase in an environmental impact of cities or mega cities. In my group, we had people in Berlin working on this green city index that we can compare different cities independent from which country they are, and that for the city organizations, for the people running a city, that they can clearly see where, for example, they can improve their city to be more ecological and going more to a green city. So let me take you on a safari. I know it's winter outside, it's snowy, so going on a safari would be nice. And I would like to show you the big urban five. And the big urban five is air pollution, water pollution, soil pollution, noise pollution, light pollution. And of course, there are many more, which when it comes to a mega city, but these are the big ones, the big urban fives. So when I started 1996 as a postdoc in Berlin and getting into these macrophyte works, you see on this picture, that's Potsdamer Platz. Potsdamer Platz, like it was 1997. Here is Brandenburg Gate. That line here is the former east-west barrier. So that's Western Berlin, that's Eastern Berlin, and here was the wall on that side. And this empty area is what you call now Potsdamer Platz. And also here there's Hotel Adlon now, then we have University of Arts in that area. This big area here is the US Embassy. And then on the other side, you have the buildings of Potsdamer Platz on that way. So there was an architect, or there was a group of architects which won the competition how to build this Potsdamer Platz. And one of them said, I would like to have this water body into this area, which should be very clear and shiny like a mirror, that when the sun is shining on the skyscrapers there, on the buildings there, it should be mirrored by the water surface on that. So for that, he said, I would need really clear water, and how to get that. So he asked the director of my institute, IGB, on that time, and the director said, Stephan, that's something for you, go on that. So I did that, and I talked with these architects, and we sit down and see his needs on that. So it should be a central part of the architecture. It should include a rainwater management, because most of the buildings have flat roofs there, and they should be green and collecting the water. The water bodies should be available for the public, always a good water quality, and therefore secure for people who are spending time in this area here. So I went back to my institute and was starting some calculations and plannings, and I was thinking on what happens if people throwing in their empty Coke cans, and you know, Coke has 140 milligram per liter phosphate. And I was thinking on what happens if people let their toddlers bath in this little lake. And yeah, you know, there's no toilet available, and the urine goes directly in the lake. So it's 2000 milligram phosphate per liter. And all these contributes to eutrophication by external nutrient input. So I was doing calculations on that, keeping in mind that the architect said clean water, that the sun gets mirrored in that. So we did calculations, and that's how it was looking like. We had this water body, that's actually this little tip here. This is the gambling hall, and this is the symphony orchestra hall. On that, we had put in these little steps that we can get oxygen into the water, and then the water gets around the corner into this bigger lake area here. So that's a view on that one. Yeah, that was the plans from the company. So a rainwater management with 2 big cisterns under that to get water into the lake if there's a dry summer. Also, we had a little pumping water from the channel of Spree into this water body, just in case there's really dry summers and the water level would drop to a certain level. Then we just put in the ideas what we brought from our institute. So we had Phyto Remediation, we had reed belts where we can filter nutrient out of the water to keep the water as clean as possible, with all the calculations we did with the Coke cans and with the little toddlers. But unfortunately, the water is nice, and if you would be able to fly there, you would see it. The water has a fairly good water quality, but what we didn't calculate in that there's not so many toddlers bathing in. There is more adult people peeing in. Of course, the volume is quite different when it comes to pee of an adult versus a toddler. So that's because we have a lot of bars and restaurants around that with outdoor facilities. And with outdoor facilities, they don't have to have necessarily a toilet area. So when people are going out and then, there was a need and the pressure, they just, put their urine into the water body. So that was a much more eutrophication pressure on that side. On the other hand, we had a lot of people putting their unwanted pets in this water body again. So we found in the beginning, we found a goldfish population, then we had some exotic carps, last time when we emptied the lakes for the fishing, then we found even a sturgeon on that and tons of little pet fish, tropical pet fish. We also had a stable population of red-eared tortoise, which are not native to Germany, but of course, in this lake, in the city, the water is not really freezing down, so they can survive there, and they contribute because they're getting fairly big, also to some eutrophication of this lake. Anyway, there are small things we can adjust and we can do for that, but actually the phyto remediation and the taking out the nutrients with at least reed was working out very well. So I was thinking on what does my green liver compares to a wetland system. And we had a student in my group who was also interested in that. So we built up a little wetland and we built up the green liver system, same volume of that. And then we run an experiment using this toxin. It's a cyanobacterial toxin. It's microcystin LR produced by cyanobacteria. And we were just putting the same amount in both systems and see how the overall performance of the system was. In the artificial wetland, we detected 13 different metabolites in the runoff water. So that's because mostly the remediation is done by bacteria and fungi in the sediment and on the roots of the reed plants. And these bacteria and fungi, they are metabolizing outside of their own body. So that's why we see a lot of these metabolites. If you only look at the parent compounds, the system performance is quite similar. But when you look at metabolites, then you see we have here 13. And with the green liver system, where the plant is really taking up the stuff and metabolizing it inside their own body and then storing it inside their own body, we could only detect 4 metabolites, which is of course because of bacteria around, which we can't avoid in this system, but we can minimize them. So then I went to China, to Hefei, to Lake Chaohu. They phoned me and I was invited to the Chinese embassy, and they said, would you like to go there and have a look at this lake? He has a small problem. So I went there. It's the 5th biggest lake in China, and the problem is eutrophication. As you can see, cyanobacterial toxins, cyanobacterial plumes. And that was the picture, actually a good day at the lake. So it's very much polluted there. And you have nearly the whole year round, you have these cyanobacterial plumes. So I was young, and my mouse was faster than my brain. So I was telling them, you can't do anything on this lake, just put concrete in and make a parking place out of that. And they were very shocked on that. And I was later very shocked that I even said this, but I told them we can try to use the water partially and try to clean it. And that I was proposing them. So here is the already treated drinking water. Already treated, yes, it looks pretty similar like the lake water, because the process is like that. You just put potassium permanganate into this kind of water, you kill the algae, but unfortunately not 100%, and that's why they are growing back. And with time, the basin where you put where you take the water out for distributing to the city is looking actually like the lake water. They also use the lake water for irrigating their little fields beside the lake. So for the food plants, for vegetables, pak choy, some tomatoes, some spring onions. And here on this wall, you can see that there are some little shrimps inside, which they also try to eat. The next picture is not so nice to look at. If you are afraid of looking an open liver, then please close the eyes and I can tell you later when you can open it again. But that's the effect. We have cancer issues in Hefei city and around in other cities, and that's around 2 persons per family. So that means 4 grandparents, 2 parents, and 1 child. And 2 of them have definitely cancer. And you can see here the liver with the cancer cells. So we built up a little green liver system. It was a little bit bigger than a tennis court. We doesn't have so much money in that, so we just use wooden plates to form these barriers. We had a lamina which are covering the surface in the first basin, the first compartment, to cut off cyanobacteria from light. And when this happens, they are dying off. And then when they die off, they set free all the toxins which they have inside as well. And this then can be taken up by the aquatic plants working in the other compartments. So it looks pretty like this, what we build up. The lake is in the back here. And the system itself was around 1,600 euros. So it was not the most expensive system in the world. In the back, you see the water treatment plant of Hefei city. So that's the result. The inflow, nice green bloom for the 46.5 microgram per liter microcystin. So if you drink this water, you will definitely get cancer on that. And then we have 2 flasks, one from the middle and one from the end. And in the end, we have 0.2 micrograms per liter microcystin LR. So we have a removal rate within 3 days of 99.5%. The WHO guideline value gives you 1 microgram per liter in drinking water as a safe value. That's based on one experiment in Australia doing with 25 pigs. And my opinion on that is that as lower as best, and even 0.2 might be too high if you have to drink it a lifelong. But it's a good start on that. So I promised you to talk a little bit more about urban water bodies, and I was working a lot with South Korea, and I was part of the Korean Institute of Science and Technology in Seoul. So with that, I was involved in some planning and some experiments which we did in a close by city, the city of Swan. Actually an area of 121 square kilometers and roughly 1 million people living in there. So it's a small city compared to the rest. It's a wonderful city, I have to say, but South Korea itself is a water-stressed country. So the city's water resources currently only fulfill 10% of the needs of the community. The dark blue area is the area of Swan, and you have some small lakes within the city area here, which are then used for providing, for example, also drinking water or water for spray irrigation. So we were allowed to work here in this reservoir. It's the Seju Reservoir. It's a man-made reservoir filled up by this little river coming here. And here is the water treatment plant of this little city. And with that, the treated water goes into this river and then ends up in this reservoir. Man-made, as I said, with a little island on that. This is a bird nesting island, so you are not allowed to go there. And it's kind of a nature reservoir here. Then this water in this reservoir is used for irrigation of rice fields. And the rice fields are just across the street in this area here. So that's the rice fields. We stand directly with the reservoir in the back and are looking to the rice fields on that. I could show that the toxins, unfortunately, are transferred from irrigation water into the rice corn itself. So it's a health risk for people eating the rice and making sushi out of it or whatever. So it's a health risk, and we have to see that we clear the water first, that there are no toxins inside, that it is safe to irrigate the water, the plants with that water. As you can see, the water looks pretty much like that. It's cyanobacterial plumes inside that. There's a lot of nutrients, so we have a eutrophication problem. We have lots of pharmaceuticals inside, mainly painkillers, because around these little reservoir are open air gyms. So people go there for training, and then they just, yeah, if they have pain, they take painkillers, and the toilets provided are emptying into the reservoir. So that means we have eutrophication, we have pharmaceuticals, we have cyanobacterial toxins, we have some heavy metals from streets and from the city around, and we also have some pesticides from the rice fields. So a big mix of everything in that. The aim was to construct an inlay green liver system, and we have to obey that. We have rising and changing water levels from 2 to 7 feet. We have wind and wave action. It should be adjustable in any size to purify less or more water, long-term durability, and a walk-on possibility, and of course a reasonable price in bonds. That would be the aim of the game. So I was going back to Berlin, and I had a good friend, Susanne Lorenz. She is an artist, and she designed this Badeschiff, or this swimming pool. And for that, she was using one of these freight components of a ship, of a river ship, and she was transforming it into a swimming pool. So if you ever go to Berlin, this is the area to be really hip. It's the hipster area, and they bath in here in a secure way. Of course, there's a bar area as well. So there's everything you need for spending a nice weekend there. And she was designing that. So I was talking with her, and I said to her, could we use this kind of a ship also to build him a green liver? And she was just starting to dream, and we had a really long evening on that, and planning and doing our things. And then with these plans, I went back to Korea and asked them, and they said they don't have these kind of ships. So we have to do something else. Lucky me, I was invited for a nice weekend in Busan at the coastline. And we were having these floating dock models where we just lay down, sunbathing, and then jumping into the water. And we were going in there by car, and there were a lot of these trucks driving around. And yeah, it shows that you only need sometimes a little bit of a holiday and sometimes a little bit of luck. And I was thinking, I can combine both. I can combine these floating models, and I can combine the canopies of these trucks and build my green liver system in Korea. So I was phoning Hyundai, and they are delivering these used truck canopies, and I get it for free, which is really cool. And then we only had to pay a little bit for these floating modules, and I was able to build up a green liver system. So now we just use plants, and we only use plants for these kind of systems which are native to the area. So we are not contributing to the problematic of neophytes. We are not having plants traveling around the world to purify water. We just use plants which are local, which are there. Unfortunately, in that area, we didn't find much. So the only thing we found was these Cladophora algae, and we were testing that in the labs before, and they were quite usable. So I was coming up with the idea of an algae curtain. And the algae curtain, why? Because I let the algae grow on this chain, and with that I can use the whole water column for purification. Normally the algae in summertime, it swims on the surface, and here growing it on these chains, I could use the water column as well. And here you can see on the little picture, you can see how these algae curtains are then looking like. So that was the design of the system, 2 compartments, a little solar pump pumping water from one compartment into the other one, 3.5 days retention time, and that's how we planned it. That's how it looked like. We had our floating models on that. We had the used truck canopy on that, and then the water comes in here, was then transferred to that compartment and then released again to the lake. So it's a flow-through system, and it was a test site for us. So that's colleagues who were evaluating the project. They were coming, looking at the system and checking whether everything is fine. In the back, you see the bird's island of the reservoir. So that's how it looks like. You see, sometimes the algae is floating on the surface, but you can also see here that it's growing within the water column on these chains which are provided to do so. That's a bigger picture of the curtains as well. And me again in my younger years with a sample of the lake water on that. So that's how my colleagues are doing the work on that. You see the algae curtains, we took samples of that, and we see how often we have to clean up the system, how often we have to reduce the algae growth, that it's not covering the whole surface. So that's a few pictures from the work there. That's actually the results. The dark blue ones are the reservoir. So this is microcystin RR in that case. And you see that it's very much present in the lake water. Then we have it in the first day in the 2 compartments, and you already can see 24 hours and we have a reduction in the amount of microcystin. And when we go to 7 days, you see that the reduction is quite a lot on that side. So that was very promising when we looked at the microcystin, at the natural toxins for using then the water afterwards for spray irrigation of the rice fields. If you look at diclofenac, at the painkiller, also we can detect it very well into in the reservoir water. We have a smaller reduction in 24 hours, and we have around 50%, less than 50% after 7 days. So that's good. It's not perfect, but it's a first step in that. And seeing that we only use one plant type, it's not too bad at all. Normally we are using 3 species in this green liver system, not only one. Then, Korea is a long flight. It's 9 hours from Helsinki and 2 hours from Berlin. So we put in some sensors and probe. We had an online data flow via satellite. And then I could sit into my control room in Berlin and have a look at how the performance of the system was. If there's something going wrong, I could grab the phone and drop an email to local employees. And if it was a serious case, which I was always hoping for because I love to be in Korea, then I took the plane and I was going there and had a look by myself what has to be done there. Another project we had, also an urban one, was in El Alto in Bolivia. Completely different. So we went there, and El Alto is a former mining site. So all the big mining companies already left. And then because it's not profitable anymore to dig out gold or gems in this area, so they left all the people there, and they are now trying by themselves to find gold in these hills. And the hills actually, they look a little bit like an Edamer cheese, so they have completely holes inside, and it's not very safe. And I guess someday this hill will just collapse on that. So the area itself, it's still suffering from these mining events. So there's a lot of heavy metals inside. There's a lot of acid in the soil, and this is the drinking water reservoir. This is the water they put in the system for providing it to the people in the city. If you go closer, it's an incredible smell. You can see the sulfur blooming here, salpeter blooming here. So it's not very nice, and you would probably not like to drink it as we did. We try to avoid drinking water from the tap in that area. The little kids, they are playing in this area. Also, the soil is very acid, and you see very often this kind of illness, and it's poisonous coming from arsenic and from mercury. because of the environment, the mining environment they had. So I went there with my students. That's my students. One of them is here and the other three are here. We were only 2 people speaking Spanish and the other one not. So we went there and we told these people, we would like to help you with the water. And they said, thank you, but we are not interested in. We have to work, we have to dig out gold to feed the families, but thanks for coming. And then we thought on, okay, what can we do? We went to the marketplace and with very simple means, we try to explain the public on the water cycle and how important it is to have clean water and how you can get rid of some illnesses with clean water. That's the students, and we made these water cycle pictures with paper and with some paint, and we were sitting in a hotel room painting this stuff, and then on the next day explaining with all means the water cycle to the people there. And you can see they were listening to us, they were coming, especially the kids were coming. So we were building up a small green liver system, and we used plastic bottles which were laying on the street, and we went to one company which you all know. It has this big yellow M as a logo, and they gave us a whole bunch of straws so that we can connect the bottles with the straws, and we can build up a small green liver system, filtering the water and showing how the system would work on that. We did this on the marketplace again. We showed the people who would like to see it. We showed the kids how it was working out. And then one day, this man come by with his kindergarten class, and he was very interested in that. And I said, okay, come to my kindergarten and build it there. And that's exactly what we did. We built up a small green liver system with materials which were laying around. So it was a very sustainable construction. The only thing we bought was the red buckets to have the plants inside to have then the water dropping from one bucket into another one. At the end, people were exhausted, as you can see on the picture, but they were happy. Because when you look at the result, the drinking water contains lead, mercury, and arsenic in a high amount. And that's what actually the children were drinking. After our system, and that was after a few hours in the system, we could really get rid of a bit of that. If it would be a longer retention time with more different plants, also that was a little bit of a problem, that we find a variety of usable plants in that area, then I think the success would be much bigger. But it was a start on that. We thought on, okay, we will come back and trying to run the system without us, with people there, and then coming back, having more ideas on how we can transform the system to be more effective. So when we came back, the whole system was not there anymore, because people were just using the red buckets for something else, and they were not really in favor of our water purification system there. So it is not existing anymore. Just giving a little details, it was 360 liters flow-through system and a retention time of 30 hours, so that could be extended, and also the volumes could be extended to be more efficient. But as I said, the buckets are used for something else at the moment. Then I was thinking on, okay, let's have a look at urban again, and the modern urban and urban farming. And urban farming is something which is very modern at the moment. And then this guy came. You all know him. It's Dark Vader, and Dark Vader was joining me, talking with these guys, and talking about urban farming, because it looks amazing. It looks beautiful. And then when you think on, you have your spices at hand, that's perfect. But unfortunately, there is Dark Vader. And Dark Vader is that our cities are more looking sometimes like that. The air quality is not like you would like to have it. There's fine dust in the air. There's kerosene in the air from the airplanes going over the city. So it's not really in a shape that you can do urban farming. And remember the big five, which I presented to you in the beginning. If you look at the vegetables when they are growing in the city, you can see that we have, for example, cadmium. That's the safety limit, 1.5 nanograms. So that's actually over the top. The same with copper, the same with lead, the same with nickel. So you would not really like to eat these kind of vegetables because you're poisoning yourself with heavy metals. So let's ask Dark Vader again, what's the solution? And he simply said, change to the dark side. And I said, no, listen, Dark Vader, that's not really an option. I'm sorry. And what else can we do? And he said, change the location. And I said, no, I don't want. I would like to do something in the city. And he said, change the location. And I said, you are very insistent, Dark Vader. And I said, no. And he said, no, change the location. And I said, no, okay, let's have a break with that discussion. So I give him a break, and then I asked him again, and he came up with the same idea. He said, change to the dark side. And I said, still no option, I'm sorry. And then he came up with something more. He said, okay, let's discuss that. Soil or hydroponic system, what would you like to have? Where does the light come from? Where does the water come from? Where does the air come from? And combining with aquaculture. And he said, on his spaceships, you know, they are really huge. If you saw these Star Wars films, the spaceships from him are really, really big. So they have the same problem like a mega city. They have lots of people and they need clean water. They need something to eat. So they have similar problems like we have in a city. And I bought then in a project, I bought these growth boxes. It was a little bit difficult to convince Technical University of Berlin to buy it, because that's the growth boxes to grow marijuana in that your neighbors are not smelling that you are doing that. So they have an inlet and an outlet for air and a filter system. They are, when you close it, they are completely closed enclosures, and you can grow your stuff in there and nobody would even see it or hear it or smell it. So that's why it was perfect for us. We use these growth boxes. There's lamps provided, there's air filtration provided, and then we only had to install these vertical grow things that little salad plants could grow in that. Then we had green liver systems to purify the water, and we developed also an air filter system. So that's how it was looking like. And the air filter, we just used mosses. We got different mosses. We let them grow on coconut mats, and then we used it in a system which was pretty much looking like a bee home. So we had these little frames where the moss was growing on that, and then we had a little box where we put it in like a bee house, and then we put the air through that, and the mosses were filtering the air pollution and the fine dust on that side. So that was the system itself, the little blue box for the air filtration, then the salad growing in that, and the green liver system purifying the water for the whole things. We had two of these systems, one which we had equipped with a green liver system and the filter system, and the other one which was not the case. And then we were growing salad. We were contaminating both systems with benzopyrene, with copper, and with fine dust. The fine dust, we just took the air from Ernst-Reuter-Platz, where the university building was located, and we put the air into our system to get on the natural situation within the city. And when we look at the numbers, you can see that the filter with the green liver was very effective in getting out the benzopyrene from the water. The same with the copper. It was significantly reduced, and the mosses were able to really filter out this fine dust that it's not on getting on the salad itself. So with this kind of a system, you can do urban farming in a more or less safe way on that. Then I was talking one day with my former department head of the IGB, and he said, that's cool. Let's combine it with aquaculture, because he was into aquaculture, and IGB is an Institute for Inland Fisheries. And then he said, yeah, we should combine it. And he did it, growing hydroponic tomatoes and just having an aquaculture of tilapia. And it worked pretty well until he needed to treat the fish with antibiotics and with pharmaceuticals, with veterinary pharmaceuticals. Then we found these compounds in parts again in the tomato, and that's what you don't want to have, of course. So if everything runs well and the fish are healthy, then it's good. As soon as the fish get some illnesses and you have to treat them, you have to uncouple the system, the growth system for the tomatoes with that. Otherwise, you have these in your tomatoes as well. Then I had a wonderful summer university with these funny guys here from all over the world. And actually, Cecilia, this lady here, she was from Venezuela. And she told me that her mother had, when she opened the tap, brown stinky water comes out. So what we did is we sit down with these people and we said, we have to help the mother of Cecile. And this is what we did. We just made some planning. I discussed with them the green liver systems and how to do it. And then we went to shopping and we get all we need to build up what you see here on the right side. It's a fridge size green liver system, the first indoor system which we constructed. So the water is here on the top and then dripping down into one compartment with plants, into another compartment with a second plant species, into another compartment with a third plant species. And then finally at the bottom, and there should be the water which you can then use for drinking, cooking, etc. We had lots of fun. We learned a lot, how to build these systems, how to cut wood, how to install a light system on that, how to put the pumps inside and let the water drop down on that. So even we did some design elements. So we had some nice plants on that side, which we thought in reality, it then could be that we have some spices growing in that and they can use also the water from the system. So we had a system as a control and we had the same system where we try to purify the water. As a marker substance, we used diclofenac again, the painkiller, because we had all the analytics in my lab on that. So we were able with that system to remove 86% within 1 day. And that's really good because the normal wastewater treatment plants at the moment, they are not really able to remove in that high percentage on this. So that's what we did again to prove everything. We had mass spectrometry to see where the plants pack it, how much they pack it, how much is in the plants, how much is in the water, and how much is ending up in then the water, which we think is the drinking water in the basement of the whole system. Yeah, we had some more dreams on that. We went to Nordvik when we know that Ed Mitchell was there. Ed Mitchell is the last man on the moon, and we had a wonderful afternoon with all my students. I packed all of them in 3 cars, and we just went to Norway, to the Netherlands to talk with him, and it was amazing. He was always telling us the main problem was that the toilet water from today was the coffee of tomorrow. So he said there was, after a few days, definitely the taste and the smell of urine on that because they recycle all water in these spaceships. And then, of course, it's not so nice if you see your colleague going again to the toilet and you definitely know you will have this water next day in your coffee. So we designed this system, which is completely sealed to help astronauts doing that. Actually, the size is that it fits perfectly into one of these modules of the International Space Station, ISS. And then it could be a water purification system for them. Of course, we had problems that when you have a cleanup of the system or you have to do some maintenance, that's at the moment something we have to solve. If you open the lid, all the water will flow through the spaceship, and that's not what NASA would like to have. So there are some small thoughts on that, what we can improve on this. We had green liver systems on wheels, so to help remote communities for short time water purification until they dig some, for good water in the ground. So we took these Mercedes Central trucks, which is a four-wheel drive truck from the Army. Normally it's used as a rocket launcher. So we used that one. We got a little model truck on that. We sent it to the UK to a colleague, and he was just scanning it in. And then we were printing out parts of that with a 3D printer, and other parts we were with the students building in my lab. Everything should be full functioning. And that's the beautiful thing on that. It was full functioning. It was purifying around 50 milliliters water a day. We did the same with a boat. So we put in the green liver into these trimaran boats. We all had the red hats on like Jacques Cousteau, because that was my hero when I was young. And yeah, that's why we had all these red hats. And again, we learned a lot how to build things, how to use plastic for that, or how to cut glass and that. And then, of course, we learned a lot how to do these green liver systems, how to balance a boat and all this kind of stuff. It was amazing. And I think students had lots of fun and learned a lot of that. And then see that. That's actually inside one of these freight models of these boats, which are going up and down the River Spree. And we had a wonderful evening and dinner on that, because we got one of these boats and we transformed it to a swimming green liver system, which is now in the channel of Berlin at the River Spree. So we can make partly purifying water. It's again a test site, and they used a lot more technique than I would like to see, but that's how it is. You have to make compromises to get what you want. Then, yeah, we had a talk with our chancellor, with Angela Merkel, and she said she would love to have a bath in the Spree Channel, and what we can do to make it safe for her dipping in and swimming around, and then just going back into Kanzleramt and doing important decisions. So we did some planning with some other people, and we came up, of course, with a green liver system looking like that, purifying in parts then the water that Angela can swim safely in the River Spree next to her Kanzleramt. Then again, I was doing some nice work and planning with Susanne Lorenz, with the artist, and that's what was very, very nice to work together with an artist as a scientist. You know, artists and scientists, they can be so happy together. And this is the Arsenal area in Venice. You would not really like to dip in for a bath. So we were just planning a green liver, and Susanne had this idea of having this safety ring. She called it an urban safety ring, and it's a nice metaphor for that, because here in this swimming pool inside, people can bath safely. The water is purified first by green liver modules and then released into the swimming pool. And when people are swimming in, you know, sometimes the toilet is too far and then they are peeing in. So we had a second system purifying the water from inside the pool before it is released outside, not to contribute to eutrophication of this arsenal area. Unfortunately, this project, it's a little bit too expensive. We got VW interested in Wolfsburg, but they were then at the end not allowed to do it because they need a person supervising the swimming pool, and they were not allowed to employ such a person as a car constructor. So that was sad, but that's how it is sometimes. We did some planning for the Innenalster in Hamburg, which is that area. If you're in Hamburg, you see that the Innenalster is that where you have this little water fountain, and the city of Hamburg said, just plan for us an area, an event area where you have a bar, a swimming pool, and that should float in this little pond or lake system. And Susanne did this and said, let's use a snowflake as that. And I was using tips of the snowflake for planning in a green liver system, and then of course the swimming pool, very similar to what she did with the Badeschiff on that. Yeah, it's a plan, not yet built, but we still hope that there will be some sponsors doing that in the future. Of course, we can make our water bodies more smart. We have a lot of small probes and sensors which we can put in the water, and then having that data loggers and sending them via Wi-Fi to satellites. And then you can even see changes in your system on the smartphone. So that's a possibility what you can always have when you are not directly next to your system and controlling it. Just a few words on environmental education, because I think it's necessary to get people as soon as possible. So we had kindergarten days with that. We had, I was going to schools. We had an exhibition at the water treatment plant on how we do it with green liver. And yeah, we also developed a lecture series called CSI Berlin. And oops, sorry, that's the wrong picture. That's the right picture, CSI Berlin, where we then just said what we can do as an ecotoxicologist to solve some of the major problems when it comes to water in a city. Again, some connections to art. We have Shioshi's survival kit for the ever-changing planet. And he said, yeah, why not having also pot plants for that? And we put it in a backpack, and then you can get the plants cleaning the air, and you can have a mask on and getting the purified air on that. That's his girlfriend, and he sent her around with this backpack in the city of Wuhan. And you see that they picked some areas which are not very nice to look at, but it's a good area to promote his art idea on that. Another point before COVID was microplastics, and microplastics, different sizes, nanoplastic and microplastic, and how to get rid of them from water bodies is an issue. And I was also thinking on how can we do that? How can we contribute to remove this plastic with simple means, not with filter systems, with high-end filter systems, but with simple ones. And I was, again, listen and learn from Mother Nature. I was, as I said, working in the former times in an institute of inland fisheries. So we had lots of fish there. And the gills of fish are most fascinating because they are very much, very effective in getting the oxygen out of the water and deliver it to the blood of the fish. So an excellent filter system. That was the idea. And I was thinking on what can we do with similar means, and the coconut idea was born on that. So we were using coconut shells and the fibers of a coconut shell to protect our water. We use different plant-based filter material. We have coconuts, we have cucumber, we have used old t-shirts, cotton wool t-shirts for that. And we also had old bags for coffee on that. And we used all these material to build up filter systems. We had these in column systems to determine breakthrough points, which one was the best for microplastic and nanoplastics. And then we saw that with coconut fibers, you have a pretty good access for different sizes of plastics. With some other materials, there is a good way, but it's not so effective. Cotton fibers or t-shirt was also very good in that. So use t-shirts, don't throw them away, just use them for filtering. And then these UT fibers from the coffee bags, they were similar to the cucumber stuff. So with this plant-based material, you can build a system for removing also plastics. So plastics which are not really taken up by plants and metabolized. So the green family in that way is growing. We have the green liver for material or for chemicals which are solved in the water column. And we have the plant gills, which we call the system, which are then filtering out the stuff which is not taken up, which is too big for being taken up, like the micro and nanoplastics. So I have a dream. And my dream is an urban sustainable living, where we have urban farming, urban safe green spaces, urban water bodies, where we can do maybe even urban aquaculture, and the water and the air is then purified by green liver and green gill system to make it in a sustainable way that we can really use the urban areas for these kind of purposes as well. And for that, I would like to open up a new chapter in our faculty, and that's maybe a competence center for the sustainable care and use of water. I think it's time for that, and if we can all work together, we could achieve that, to have this kind of a center very similar to what we have with CEOs in our faculty at the moment. And I hope it will be in the future similar, successful like that. So I can't do this alone. And this is my A team. And I love when plants working out, even I don't smoke cigarettes. So that's the people behind all these plans and all these projects I showed you. A wonderful team, together with my colleagues from all over the world, and some of the colleagues were even getting my friends. So we were all doing in the past really years promoting and testing these green liver systems. Also, I would like to thank, of course, my teachers, and all of my teachers always said to me, be part of the solution, not of the problem. And I always keep that in mind when doing my research. So for that, I thank you very much for listening to me. Merci beaucoup. And keep calm and ask your ecotoxicologist if you are in need of. Thank you very much.
Thank you so much. Lots of beautiful pictures taking us all around the world, around water issues. And we have a number of people who have identified that they have questions. We'll start with Marika. Go ahead, Marika, if you can unmute.
Hello, thank you. I was really curious when you're talking back on the planning stage with all the different plants and like the systems, in terms of planning these projects in different countries, how are you choosing the local plants?
It's very easy. We just walk around. We look at nature. That's what we do. We ask locals where are water bodies. We go there with them. We just look what plants are inside. We have at the moment a huge database on plants, and we then of course see, is this plant already in our database? If not, then we have to pick it and we go back in the lab. We make some tests with these plants, of course not with all chemicals known, but with some of the major chemicals to get a feeling what the plant can do for us. And then we can include them into our list, and we can maybe hopefully use it for a local green liver system.
Thank you.
Thanks. And the next is Uriel.
Hi, Dr. Lima. Couple of questions. First, do the plants just eat the toxins, or does it remain in the plant? So Do the plants need to be frequently removed, safely disposed, or just not a problem? And I have another question. You probably are aware that there is a number of First Nation communities facing a severe issue with drinking water. So do you think that this could be a solution for them? Thank you very much.
Answering your first question, the plants are taking up chemicals, and the plants could not really choose what they are taking up. They are taking it up. Some they have transporters, and then they take it up better than others. But yes, they are kind of eaten up the problem. Then they are storing these metabolites after metabolization in vacuoles or in cell walls, in apoplast areas of the plant itself. So it is packed. It is packed in the plant. That also means if the plant is dying one day, everything will be set free. So we have to see that we treat our plants in a good way. We have to keep them healthy and in a good shape. And if we see that they are exhausted, that they are not doing the performance we would like to see anymore, we have to partly remove them from the system and then plant new plants in. So that's a constant work you have to do, depending on, of course, how much pollutants you have in the water. And when it's a very polluted water, you have to do it much more frequently. So also you have to see on the climate area you build on your system. If the water is freezing, there is no plant. There is no work from these plants because they are dead or frozen or in a remote state. So then you have to think on something else to purify the water, or you have to heat up pools, or you have to have it in a greenhouse, whatever. There are possibilities. So you have then contaminated plant material someday. And this contaminated plant material, you can just try to get rid of them in burning it, which is maybe not the best way. And we were thinking a lot how to do it. And then our South African friends coming on the plate. And they said, why not mixing it with wood saw and pressing it to little pellets and distributing these pellets to people that they can use it for cooking. So putting it in their kitchen oven and use it for cooking. That's actually a nice idea, but of course we have to see whether these pellets are safe to handle. If you put it with your bare hands out of a sack and put it in your oven, so they should not transfer toxins in from the plant material, from the pellets into your skin. So this has to be tested out. And also what happens if we burn that in a normal kitchen oven? Is that enough to be safe on that side? So this has to be tested out and worked on. Otherwise, it would be nice because the local communities can build up a small company, getting the plants from us, drying the plants, mixing the plants with wood saw, pressing the pellets and distributing them as their own business. So that would be the idea. Looking at indigenous people here in this area, I think, and I'm sorry if I say it like that, it's a no-go if people have to boil water to drink it. That everyone has the right for pure and good drinking water. And in a pandemic like we have at the moment, it's having not clean water is an additional stress factor. And we have really to avoid these kind of things. So I hope that the systems we have so far might be helpful also here in Canada for providing people with good water and with good water quality. Of course, climate conditions. If I look out of the window, I see snow. That's the same what I saw in Helsinki when I was there the last 3 years. And I was partly also in Helsinki to see how we can adapt the green liver system to the climate conditions, to freezing water. And the plan was then building it in a greenhouse and heating up the greenhouse with thermal energy. Of course, you need light. Plants without light would not work as well. So you need a bit of energy on getting them growing through the harsh winter time. And As longer the winter, as more energy, of course, you would need for that. But there are possibilities, and that's why I'm here. Hey, we can explore that together and can see what we can do.
Thank you. The next person, Yanan, asked that I read these questions out. How do you manage the green liver system? Is it easy? Is it economical? That's one of her questions. She had a number of questions. One was already answered. What is the lifetime of the green liver system after solving the problem? And is this system, does it influence the ecosystem of the river or lake competing with native species?
Yeah, the last question first. We use only native species from this region, so we are not really changing things there. We have an accumulation of native plants in our system, and if some escape, which can happen, they are not neophytes in the system at all. So that's nothing to worry about. I'm old. I forgot the other ones. Can you read it again for me, please?
Definitely. Is it easy to manage the green liver system?
Okay. We find it very easy, especially if we use some of these little tech tools which we have. So if we have some sensors, some stuff which we can look at from our mobile or iPad or whatever, it makes life a little bit easier. But the most easiest thing is to train people, to train normal people and show them how they can do it and how they can really manage the system. And that's what we did in Africa. That's what we did in Brazil. That's what we did in China. And it worked out quite well. So the management is not a book with 7 seals. It's very easy to do. And we are always there to help out and to give advice on that. You know, I love traveling. and I'm happy to fly around the world and being there and talking with the people and giving advice on that. But at the long term, they should do it by themselves. That's how it is. They should learn how to do it, and we are happy to transfer the knowledge on that.
Excellent. And Uche, and then Camillo, because I'll be reading out Camillo, so we'll give a break and let Uche speak.
Thank you so much, Dr. Lima, for the excellent presentation. It was so exciting, and thank you also for bringing me back to the past. So I have a couple of questions. One is looking at the water body in Berlin, so heavy boat traffic, attracting tourism in thousands every day. So does that have an impact on the water body in the city? And that's one question. The second question was the project in Bolivia where the locals rejected the innovation, because I'm interested in innovation adoption. You made a lot of examples using it in space, and now with air pollution also helping, and you also talked about using different materials like shed to remove plastic. And I did put a question there about that dye, but the Bolivian case study, apart from what I call the urgent need, which is people to survive first of all, because they want to survive with mining gold. But what other problem do you think might have contributed to the people rejecting what you think is a very fabulous and super innovation that could help them to get a safe drinking water? And Yura have also just asked if this can be applied in our community, in our country, especially among the indigenous people. So what lesson do you think contributed to the rejection of the innovation in Bolivia?
I think if I can answer the second question first, it was us. Simply, we went go there and we thought we rescued the world. Forget that. You have first to include the people into that, and then you can rescue the world. But you have to do it together with the local people, and that's what we are forgetting when we arrived there. We were there and we were just putting our arms up and said, where's the problem? And we do it, show it to us. And then we learned that the people there are very, very poor. They're living in very bad conditions. They try to feed the family with the less amount of gold they get out of these hills. And that's their main worries. It's not the water, it's even not the bad water, it's that they have enough money to buy food for the family. And we have to understand that. Going there, we thought on, and that was actually something which I experienced by myself when I was a kid. I was in school, and during that time, the phosphorus in the detergent of washing material was a big issue. So my teacher, she was talking to us in the kindergarten and said, you know, phosphorus is bad for the environment. So maybe you can talk with your parents on that and tell them that phosphorus is bad. So I was, you know, I have pictures with that, with a little lederhosen on, and I was standing in front of my mother and said, Mama, phosphorus is bad, use something else. And I did this. I can be very insistent, I tell you. So, and with time, she was just trying to buy some alternatives. So the teacher made it right. She was going via the children to the parents. And the parents, sometimes they don't have the time to listen, but the child have time to listen and to learn. And that's how it is. And that's what we then did. I did then remember, and I said, let's go to the marketplace. Let's talk whomever we find there and whoever is interested in there. And if it's kids, it's perfect. And that's how we started up with that. We talked with the kids and we went to the kindergarten. And then, of course, in that area, when you are not really present, then these 6 red water buckets are precious for them, precious for doing something else. And we have to accept also that. So yeah, the next thing what we were thinking on is we have to build it in a different way. And maybe the Korean idea with the used truck canopies would be an idea doing that we have a more sustainable system where we use even more used materials in a sustainable way to build up these kind of things. So I'm not angry on that. I'm angry on ourselves that we are not really listening to the circumstances on that. And of course, we would now change it on a way and just learn what we did wrong and try to make it better. With the Berlin things, impact of tourists, before COVID, Potsdamer Platz is one hub. It's if you have a tourist, he goes to Potsdamer Platz. There's Sony Center, there's Mercedes, there's the gambling hall, there's big shopping malls. There is the company with the big M. We have a lot. And of course, if you have thousands of tourists per day walking by, it has an influence on that. And also all these skyscrapers around and the wind which is caught between the buildings, that has an influence on the accumulation of pollutants in the air and then later on the surfaces and also in the water itself. And yeah, as more tourists coming, as more severe gets the problem. 1997, that was smaller than we had before COVID. 2017, 2018, there were tons of tourists there. And of course, people throwing their rubbish somewhere, so they are not really taking the trash bins, and that's a problem, but it's a problem of education. It's a problem of educating people not to throw their rubbish into the environment. So it's again a problem what we have, not the environment.
Thank you. Now we have 3 more questions. Do you have 5 more minutes or so to answer them?
I have a next meeting, but don't worry. I take my time. No, no worries
Okay,
on that.
excellent. And so Camilo asked me to read this. As part of a remediation method for stormwater management systems is to retain water and subsequently release it to the city's pipes. Did you, from your experience and according to the project that you mentioned, where architects asked for crystal clear water, did you encounter a problem concerning the inflow and outflow of the water, and any outflows were experienced? So I think this is related to some of our pipes are combined sewer overflows, so the sewers overflow into the river system and
Yeah.
flood the wastewater treatment plants.
Yeah, stormwater is it collects everything from the city. Yeah, so everything you throw on the street, everything it comes as a wash out from surfaces of buildings or from roofs of buildings. When you wash your car, when the car is leaking, when you're just walking by, even with sneakers, it's 4 gram microplastic per year with your sneakers walking just in the city. So everything ends up in stormwater, and there are some stormwater where it's purified partly, and some of the stormwater goes directly into the lake, which was in my latest hometown, Lahti. All the stormwater was just going into the lake and ends up there. So we can transform, especially the plant gill system, for working into these pipes. And we had some nice ideas of rotating discs on that are then filtering the rubbish out of that water. And then you have to remove these filter cassettes and putting new ones in and cleaning that or dumping that. That was not really, we were in the middle of thinking on that when I changed the location. But that's something we can develop, and we have to develop in the future. Yeah.
Thank you. And Pepper, and then I'll read out Kima's, and the very last question will be by KSAP.
So thanks, Shirley. Thanks, Dean, for that presentation. It's just such a breath of fresh air to hear that the foundation of this work was based on the relationship with human body. I feel like as a nurse sometimes in this faculty, we don't talk enough about the relationship between human health and environmental health. So I feel like we have a lot in common, especially around our research. So the research that I look at is healthy built and social environments. And so it looks exactly at this, how we're building our communities and whether or not it is advantageous for human health or whether or not we're actually digging our own graves. And I feel like I had so many questions right after your presentation, but then you dropped a bomb at the end around this vision for a center. And I feel like we could go for another 3 hours just talking about that. So maybe I'll just ask a real quick question then. So your vision for the center, are you still in the planning stages of that? Is there going to be a call for volunteers to help plan and dream this vision of yours, or what's the next steps for that?
I'm the dean since 5th of October. Since 17 or 19 of September, I arrived in Canada. So the first aim what I have is to be a good dean and to learn about my faculty and how to guide them through all these money cuts what we have at the moment. That's priority, definitely. The water center is second priority in that, because I have to learn first what other provinces are doing. They have water centers already. Most of them is for monitoring purposes. And I would like that our water center is going far beyond. That's the aim. We don't need another monitoring system and to tell us how bad or whatever is our water. We need solutions. And that's what I would like to see that our water center is offering with that. And as I said, I need another A team for that. So everyone is welcome to contribute and to be part of this A team. And please, in a few years, then let me say the same sentence. I love when plants working out. Even I still not smoking. So that's how it will be. It's on the plan. And we are doing things on that, in that direction, talking with people in the faculty on that. I would also like to see that a big part of the center is with these grassroots effects, that people like you, people here in this community coming up with ideas. I see Jennifer being here as well, and she's already very helpful, sending me links and giving me information, which I as a foreigner don't have at the moment. So I'm very happy to have that. And there will be a time when we set up these, and then we will have discussions before where I will invite as many people as possible to get a base on people to help me setting up this center. So if you volunteer, perfect.
Excellent.
Okay, thank you so much.
Thank you. Great question. And the last question, I believe, is from Chima. Kesab mentioned his question was answered. On the basis of sustainability and self-sufficiency, how best can the vulnerable indigenous communities key into the merits of smart water bodies application?
Yeah, we were thinking on that when I was working in South Africa and in Kenya, because sometimes they need it fast. They need it actually the next day. And that's why we came up with these green liver on wheels, because we can go there and we can have some water with us to give the plants in this area when we put them into our truck system a good start. And then actually 24 hours later, you can get the first clean water out of the system. So that's a very fast thing, but it's not the most sustainable thing. So the most sustainable thing would be then to plan with the local community where to put a land-based system or a swimming system, how to build it up and how to run it. But during that planning time and building time, you can have these truck system mounted on a truck and then get the water immediately. So it's a matter on how we can do it. And of course, I didn't tell you that, but the Mercedes Zetros in the basic version, that means without any radio or whatever luxury things, it's 168,000 euros. Of course, also without the rocket system, which we don't need really. So the rest of that, the lab system in the back, the green liver system in the back, that ends up with being around 250,000 plus. So each of these trucks would be around 350, 400,000. We talked with Mercedes-Benz on that, and they said, yeah, you can, of course, you can order one, but the order timeline at the moment is 10 years to get it, because all the trucks is at the moment going to our army on that. And they are not building it like a VW. There are not thousands of them coming out of the factory. So that's only a handful of them. And at the moment, for the next 10 years, it's reserved for armies in Europe and in Germany as well. So after that, we can think on that. The only other suitable car would be a model from Russia, which has also four-wheel drive on all wheels on that, but the price is pretty similar. And it's also used as a rocket launcher. So the possibility to get one is at the moment small. But maybe, you never know how it comes, and there will be an opportunity to get one. And then we have to see how we find sponsors who were able to put out the money and to help us with that.
Great. And Kesab did have a final question. I'll just put in a plug. New Flyer has electric buses and produces them here in Winnipeg. So possibly there's some products here that would work. And Kesab, I want to thank for organizing the webinar and reaching out, and he did a fabulous job, and it's live streaming right now. So go ahead, Kesab, for the final question.
Thank you, Shirley. Thank you, Dean, Dr. Lima, for your presentation. It's a great experience to hear from you. I came from Nepal, so it's a mountainous ecosystem, and I was thinking how this system could work in that context. So my question is, because in a mountainous context, what happens in the river system or in the lake system is dependent on how interventions or operations are organized in the terraces or in the watershed. So would you consider like those forestry activities, bioengineering activities as a part of this green river system, or it has to be something very much focused on the water bodies? Thank you.
No, what I learned is that green liver system is not the only thing making you happy. That's how it is. We can't solve all the problems. That's impossible, and we would love to do that, but it's not. We have to combine systems, and it depends very much on the location. We have combined it with traditional water treatment. Then our system, maybe a plant gill system, maybe a nanofiltration device. So we have the combination of different systems in a good way makes the thing really running and well. So sometimes it's enough to have a green liver. Sometimes it's better to have sand filtration, green liver, and ozonation in the back. So that's how it is. Combination and being open for every solution. That's what we need in that context. And then, of course, we have to see the locations. Yeah, Nepal, up on the mountains. If you look at the prairie here in Winnipeg, a flat land, lots of cold weather, lots of wind. We have to see how we can adapt the system on that. And I had a wonderful student in Helsinki, and she was so creative and thinking on what can we do to make the green liver fit for a winter. A Finnish winter is minus 20 degrees. So we have minus 30 here. It would only be a small increase of or decrease of temperature to run it here as well. And that's what I said. I need you. I need you thinking on that. I need ideas on that. I need another A team doing that. And that's how we should go forward with that.
Thank you.
So thanks a lot for that question, and all the others also thank a lot for all the questions. I would love to have more time discussing with you, but yeah, join one of these events, talk to the dean, and we can just have an evening talking on that. That's not a problem.
Lovely. Thank you, everyone, for participating, and particularly to the dean for engaging and creating a possibility for regeneration and hope. I think in a polluted society, we need these kind of ideas that get out of the box and get us into a greener future. So thanks again, and I'll say goodbye to everyone now. Bye.
Bye-bye.